Hi. So in this problem, we are going to look at a probability question. This is from an Allen score test for JEE Advanced. And this is an interesting problem. So we'll look at how to analyze it. And let's just get started. This is a long paragraph type of question with a long series of steps. So first I'll explain what the problem is. So the problem says you consider three sets. E1 is equal to 1, 2, 3, F1 is 1, 3, 4, and G1 is 2, 3, 4, 5. Now, two elements are chosen at random and without replacement from the set E1, right? So you choose two elements from this set. Let S1 be the set of those chosen elements. So when you have chosen those two elements, you call it S1. Let E2 be E1 minus S1 and F2 be F1 union S1. F1 is this one, and you take S1 as the set of those two chosen elements, and you do F2 is equal to F1 union S1. Now the second step is two elements are now chosen from the set F2, which we just now made here, without replacement and at random, right? And let's call that set as S2. Again, you are defining a new set. G2 is G1 union S2. And then finally, again, two elements are chosen from G2, this new set. And we are calling it S3. And we are saying E3 is equal to E2 union S3, right? Now, the question is, given that E1 is equal to E3, E1 was this original set, and E3 is what you did, what you got here after doing all these steps, right? Given that E1 and E3 are identical sets, let P be the conditional probability of the event that S1 was 1, comma 2. So in the beginning, when you chose the S1 set out of two out of these three, that could have been 1, comma 2 or 1, comma 3 or 2, comma 3. So the conditional probability of the event that initial set S1 was 1, comma 2, we have to find what is the condition that is given to us? This, given that E1 is equal to E3, right? So we have to find this probability P. Now, obviously, there are a lot of symbols, a lot of steps. So sometimes students get overwhelmed by just looking at the problem. It looks very big and very difficult, but actually it is not difficult. What we want to analyze here is how to approach these kinds of problems. So the best way is to organize your solution very well. You should draw a tree diagram. Basically, a tree diagram is basically enumerating all the possibilities that will happen, right? Once you draw a diagram, you will realize what are the paths by which we can reach our desired outcome. What is our desired outcome? Our outcome is P, the conditional probability of the event S1 is equal to 1, comma 2, right? So I will just try and analyze this question now. So we'll go over to the next screen and we'll say, finally, what do I want? P, which is the conditional probability of E1 equal to E3 is given. And you want to say probability of S1 being 1, comma 2, right? That is my P, right? So this part is already given. So I should not draw the symbol here. I should say probability of this given this, right? Great. So how do we calculate conditional probability? We should find P should be equal to probability of this event and this event, intersection of these two, right? So probability of E1 is equal to E3, this event, intersection with S1 being 1, comma 2, right? And this divided by probability of the conditional thing, whatever is the given condition, the probability of E1 is equal to E3. This is the basic definition of conditional probability. So ultimately, I want this probability, and this probability. Probability that E1 is equal to E3 and also the probability that both the things happen together. S1 should be 1, comma 2 and E1 should be E3, right? Okay. So we will keep this in mind and we'll analyze the question accordingly, right? So what I want you to understand is from the beginning, there were many choices, right? So we'll try and draw a rough tree diagram, which will give us a sense of what we are doing. So I will write E1 is equal to 1, 2, 3, the data of the question, the initial stuff that we know already. F1 is 1, 3, 4, and G1 is 2, 3, 4, 5, right? Okay, great. Now, what were the steps involved? The first step in the problem was choose two elements from E1, and that becomes your S1 set, right? Call that S1, right? That was the first step. What was the second step? We say E2 is equal to E1 minus S1 and F2 is equal to F1 union S1. What was the third step? The third step was choose two from F2 and call that S2, right? Fourth step. Fourth step was say that G2 is equal to G1 union S2, right? Fifth step. Fifth step was choose two again from G2 and we call that as S3, right? This was the fifth step, and the last step, I will write it here. Step number 6 is call E3 is equal to E2 union S3, right? This was my last step, right? Okay, so I will keep this information in mind and I'll follow that process, okay? So first step, if I want to do, choose two elements from E1 and S1, right? Okay, so this is step 1. Step 1, to choose two elements from E1, I could choose S1 could be 1 comma 2, S1 could be 1 comma 3, and S1 could be 2 comma 3, right? These are the three paths, right? I hope everyone is understanding. I'm dividing my problem into a tree diagram and I'm saying I have done the first step. I have chosen two elements from E1 and I'm calling that S1, right? Okay. So what we will first analyze is the case that S1 is 1 comma 2, right? This path we'll analyze. Okay. So here, what is E2 here? E2 is E1 minus S1. E1 minus S1. So E2 should be just 3, right? And also F2. F2 should be what? F2 should be F1 union S1. F1 is this, union with S1 would give me 1, 2, 3, 4, right? If I do union of 1, 3, 4 with 1, 2, it will be 1, 2, 3, 4. So my step 2 is done, right? Correct. Now again, I have to choose two elements from F2 and call that S2, right? I have to choose two elements from F2 and call that S2. How can you choose two elements from here? Obviously, there are 6 possible ways to choose, right? 6 possible ways. So you can choose 1, 2. So your S2 can be, I can divide it into 6 cases, right? S2 can be 1, 2, can be 1, 3, can be 1, 4, can be 2, 3, can be 2, 4, and can be 3, 4, right? These are the 6 ways in which you can choose your S2, right? And in each of these cases, G2 will become G1 union S2, right? So G2 here will be 1, 2 union G1, 2, 3, 4, 5 union 1, 2. So that will become what? 1, 2, 3, 4, 5. Here 1, 3 with this will also become same. This will also give the same thing. 1, 2, 3, 4, 5. And here we have 1, 4 with this. So again 1, 2, 3, 4, 5. And when you do 2, 3, you get just 2, 3, 4, 5. Right? And we get 2, 4. You get what? 2, 4, you get 2, 3, 4, 5 again. And 3, 4, that case you will get 2, 3, 4, 5 again, right? This is what? This is my set G2, correct? This is my set G2. And now finally we have to choose 2 from G2, right? 2 from G2 such that that will be called S3, right? So you can choose any two. There will be many cases here, right? But ultimately, what do we have to do? Ultimately, E1 should be equal to E3, right? That was the conditional probability that we needed, right? So E1 is 1, 2, 3. And what is S3? E1 is E2 union S3. We have already gotten E2, right? Notice here we have already got an E2. So E3 is E2 union S3 and E2 is 3 union S3 is E3. So if E1 was 1, 2, 3, so then this E3 should be 1, 2, 3 should be equal to 3 union S3. So that means that S3 should be 1 and 2, right? S3 should be 1 and 2. Are you understanding what I'm saying? Because at the end, my E1 and E3 should match. I already know E2, which is 3, and I already know E1, which is 1, 2, 3. Therefore, E3, therefore, S3 should be 1 and 2, right? And S3 was selected how? S3 was selected in the fifth step where we choose two elements from G2, right? So we have to choose two elements from G2 so that you get S3, right? So notice you can do it from here. 1 and 2 can be chosen from here, 1 and 2 can be chosen from here, 1 and 2 can be chosen from here, but 1 and 2 cannot be chosen from here and cannot be chosen from here, right? So basically you are saying and cannot be chosen from here also. There is no 1 here, right, in G2, in these three branches, right? So only these three branches you can choose 1, 2 so that you will get the final condition, right? Okay. So what is the probability of choosing 1, 2 from here, right? So probability of choosing 1, 2 as the pair would be 1 by the number of pairs possible here, right? So it will be 1 by 5C2, right? Do you understand that probability of choosing here 1, 2 would be 1 by 5C2, right? And similarly here also 1 by 5C2 because 5C2 is the total number of pairs possible here. And here also 5C2 is number of pairs, 5C2 is number of pairs, and you choose only the correct pair 1, 2, right? So the probability of choosing the correct S3 in order to get our final condition of E1 equal to E3 will be 1 by 5C2 here, 1 by 5C2 here, 1 by 5C2 here, right? Now, in this path, the probability of choosing 1, 2 was what? That is just one pair out of the 6 possible pairs. So this was 1 by 6, right? This was 1 by 6, correct? This was also 1 by 6 and this was also 1 by 6. Only 3 paths are giving us the correct answers, right? Correct. Only these 3 paths are giving us the correct answer. These 3 paths are not useful because from there finally we cannot choose 1, 2 for S3, right? These 3 paths. These 3 paths are not useful for us. So if you think about it, the probability of having, okay, I will write it here. The probability of having E1 equal to E3, right? E1 equal to E3 is going to be 1 by 6 into 1 by 5C2 here, 1 by 6 into 1 by 5C2 here, along this path, and along this path also same. So, and along this path also same. It is 1 by 6 into 1 by 5C2 in these 3 paths. So it is 3 by 6 into 1 by 5C2 total probability, right? And what was the probability of choosing this path? Where we started off with S1 is equal to 1, 2, right? That probability was obviously simply 1 by 3, right? So what am I doing actually? What I'm saying is you start off with one branch here. The probability of choosing this branch is 1 by 3. Then in this branch, you have 6 possible pairs of 2 elements. So each probability is 1 by 6, 1 by 6, 1 by 6. And 3 of these are not allowed because from there we cannot get the final E1 equal to E3 condition, right? So 1 by 3 for this step, 3 by 6 for this step, these 3 branches. And in each branch, you have to choose a pair. So that will be 1 by 5C2. So if you calculate this, this is coming 1 by 6 into 1 by 10. So 1 by 60 probability, right? So probability of getting E1 is equal to E3 and S1 is equal to 1, 2 is both the things are happening together here. S1 was chosen as 1, 2 and E1 equal to E3 at the end. The overall probability was coming out to be 1 by 60, right? Now let's analyze the other 2 branches also because finally we have to calculate probability of E1 equal to E3 intersection with S1 should be 1, 2 divided by probability of E1 equal to E3. This was the conditional probability that we needed, right? We have already found this top part. We have found that was 1 by 60 because we took the branch where S1 was 1 comma 2, and in that we got 6 options here. So 3 by 6 was the probability because 3 were the correct options because these 3 don't lead to E1 equal to E3, right? And here inside, each time you chose G3, finally it was 1 by 10 probability. So there were 3 such branches. So we got 3 by 1 by 1 by 10 into 1 by 10 into 1 by 10. And no, I'm making a mistake here. What I was doing was 1 by 3 for selecting this branch, then 1 by 6 for selecting one particular thing here, and 1 by 10 for selecting the final thing. And you add this 3 times, right? So if you add this 3 times, because this is also a path and this is also a path, right? So you would have gotten, if you add this 3 times, basically it's like multiplying it 3 times. There are 3 branches like this. So finally 1 by 60 was the probability. But you have to realize that that is the probability of this. If I wanted probability of this, I have to take other branches also, right? In the other cases, when S1 was 1 comma 3, right? If S1 was 1 comma 3, it is still possible to get E1 is equal to E3 there, right? And even if S1 was 2 comma 3, it is still possible to get E1 is equal to E3 there. So we have to add those branches to get the overall probability of E1 equal to E3. This probability will be larger than this probability. Why? Because this is a more restrictive condition because 2 things have to be together, right? So we will look at the other branches now. So let's assume that S1 is equal to 1 comma 3, right? And E2 is equal to now, what was E2? E2 was equal to E1 minus S1. E1 minus S1, E1 was 1, 2, 3, and E1 minus S1 will be just 2, right? And F2 would be equal to, basically, F2 was selecting, F2 was F1 union S1. I am at step 2 right now of the process, right? This is step 2. I have chosen S1 is 1 by 3. I have calculated E2. And now I'm calculating F2, which is F1 union S1. And F1 union S1 is what? F1 was 134. Union with S1 will give me 134 only, right? This is step 2, right? Now from here, I have to select basically 2 elements from F2 and call that S2, right? So F2 is 134. The 2 elements here could be 1, 3, could be 1, 4, and could be 3, 4, right? These are the 3 paths here, right? Great. Now we will say G2. G2 is G1 union S2, and this was called, this set was S2. S2 had 3 options basically, right? And G2 is G1 union S2, and G1 is 2, 3, 4, 5, right? G1 was 2, 3, 4, 5. And if you do union S2, you get G2 here will become 1, 2, 3, 4, 5. But 1, 4 union with this will again give 1, 2, 3, 4, 5 here. And 3, 4 union with this will give 2, 3, 4, 5. 2, 3, 4, 5, right? These are the options for G2. Once we have gotten our G2, we have to select 2 elements from G2 and call that S3, right? And finally, E3 was equal to E2 union S3. And finally, E1 should be equal to E3. So that means 1, 2, 3 is equal to E3. And E3 was what? E2, which is 2 union S3. So in order for E1 to be equal to E3, what I have to see here, 1, 2, 3 should be equal to 2 union S3. So that gives us S3 should be 1, 3, right? Because 2 is already there. So S3 should be 1, 3. So finally here, when you select 2 elements from here, you have to select 1, 3, right? There are many ways to select 2 elements. This path is okay because we can select 1, 3 from here, right? This is also okay, but this is not allowed, right? Because you cannot select 1, 3 from here. So when you pick two elements from here, the probability of choosing 1, comma 3 is 1 by 5C2 again. And here also it is 1 by 5C2, right? Correct. So there are now two branches here, which works out. So at this stage, this path is not allowed because this doesn't give us E1 equal to E3. So 2 out of 3 paths here are okay. So the final probability in this case would be 2 by 3 into 1 by 5C2 and 1 by 3 overall, because we started off with this 1 by 3 probability of selecting this, right? So here the answer for these cases will come out to be 1 by 10 here, and this is 2 by basically 90, right? 2 by 90 is coming out to be the probability of getting E1 equal to E3 if your S1 initially was chosen as 1, comma 3, right? So keep that number in mind, and we'll go to the third possibility, right? In the third possibility, step 3, we start off with S1 should be 2, 3, right? And this happens with probability of 1 by 3, obviously, right? And then we go to the next steps. We do the same thing again. So think about it. If S1 is 1, 3, then E2 is equal to 1 and not E2. E2 is equal to 1 and F2 is equal to 1, 2, 3, 4, right? This is step 2, right? And this is branch 3 actually. I should not write step 3 here. This is the third branch of my tree diagram. Branch 3 and F2 is this. This is the step 2 of it. Now we choose two elements from F2 and we can see there are different possibilities. You can say this is my S2. S2 could be 1, 2, it could be 1, 3, it could be 1, 4, it could be 2, 4, it could be 2, 3, and it will also be 3, 4, right? Great. Now G2 basically would be the union of G1 and S2. G2 is the union of G1 and S2. So what was G1? G1 was 2, 3, 4, 5. So G2 would be here 1, 2, 3, 4, 5. Here also it will be 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. And in the last three sets, it will be 2, 3, 4, 5 because it was union of 2, 3, 4, 5 with 2, 4, 2, 3 and so on. So here it is 2, 3, 4, 5. Here it is 2, 3, 4, 5. And here it is also 2, 3, 4, 5. Right? I'm just following the steps in a systematic manner, right? Now we can work backwards again and we'll realize that E3 was equal to E2 union S3, right? And E2 was 1, and E3 should be equal to E1, which is 1, 2, 3. So that tells us what S3 should be, right? S3 should be 2, 3. S3 should be 2, 3, right? So I have to choose 2, 3. And obviously it is possible here, it is possible here, it is possible here, it is possible here. All the 6 branches are possible, but the probabilities will be different. So picking 2, 3 from here will be, probability will be 1 by 5C2. Here also 1 by 5C2. Here also 1 by 5C2 because the total number of pairs is 5C2 in these 3. And here it will be 1 by 4C2, 1 by 4C2, and 1 by 4C2, right? So the overall probability here is 1 by 3 for this first step, right? 1 by 3 for the first step. Then you could pick any of these branches. All of these branches are allowed. So it is 1 by 6 for each step, right? 1 by 6 for this branch and then 1 by 5C2 here, right? And similarly, here also and here also. So it will be 3 times this, right? Plus for this, it will be 1 by 3 into 1 by 6 into 1 by 4C2, and similarly 3 times here because there are 3 branches with 4C2 probabilities at the end, right? So ultimately you are getting this, you are getting 1 by 60 plus this is 4C2 is basically 6. So it is 1 by 60 plus 1 by 36, right? So that becomes 16 by 360. Let's keep it like that. So this was branch 3 and probability of getting E1 is equal to E3 from branch 3, right? Now, finally, my probability was E1 equal to E3 intersection with S1 was equal to 1, 2 divided by probability of E1 equal to E3, right? So this was basically, this was the first branch that we calculated. That probability had come out for us and that probability had come out as 1 by 60, right? And E1 equal to E3 can happen in 3 different ways. This can happen when S1 was 1, 2. This can happen when S1 was 1, 3. And this can also happen when S1 was 2, 3. And each of the branch individual probability of getting E1 equal to E3 we had calculated. This one is simply 1 by 60, which is there in the numerator. This one came out to be, we calculated it as 2 by 90. And this one came out to be 16 by 360, which we just now did branch 3, right? If you are getting confused at any step, go back and rewatch those relevant sections of the video. You should understand it better. So what we'll write here is 1 by 60 plus 2 by 90 plus 16 by 360. And that becomes, the top part is 6 by 360 divided by here, it is 6 plus 8 plus 16 by 360. So you get basically 6 by, this is 14 plus 16, 30, 6 by 30, and it is 1 by 5. So the final conditional probability is coming out to be 1 by 5 or 0.2. And that is your answer. So I understand that the problem is long and there are many things to consider. You have to do it carefully and slowly and in a methodical, organized manner. So what we have realized is, start with the steps of the problem, outline the steps of the problem. You have to go in a sequence. And in each place where there are multiple choices, you should split your tree diagram and analyze one path till the end, right? How do you do it till the end? You have to realize at one stage, you can work backwards with E1 equal to E3 and get the relevant S3 set that was needed at the end, right? So sometimes some branches were not giving S3 sets. So only that particular branch you have to calculate the overall probability. If you are getting stuck in this, please go through the video again carefully. I think it should be clear once you rewatch sections of it and try it yourself. I think you'll get the answer. So this was an interesting problem I wanted to show you guys. More problems will be forthcoming. We'll be discussing many more questions for JEE Advanced aspirants. And if you like the video, please share the channel, subscribe to the channel, press the notification icon, and I'll see you in the next video. Thanks.